Okay, the final type of binomial question you may be asked about in the exam is a type of question whereby they're asking you to work out a missing power. So let me show you some examples. Okay, question 1. Okay, in this particular example, they'll say, for a given binomial expansion, so we might take x plus 1 to the power n. Okay, notice in this particular case we do not have a number for the power. It's a power n. So in that particular binomial expansion, they'll tell you some information, and that information will be used to help you work out what the value of the missing power n is. So for example, we might say that the coefficient of the fourth term is equal to 2 lots of the coefficient of the third term. So they're giving you that information, and from that information they're asking you what is the value of the power n for that to be a true statement. Okay, this is how we go about it. Coefficient of the fourth term. Well, the fourth term is going to have a choose value n choose 3. N because it's a power n. So if it was a power 7, you'd have 7 choose 3 for the fourth term. It's a power n, so we'll have an n choose 3 for the choose value for this particular coefficient. If it's n choose 3, then the second term will be 1 to a power 3, and the first term, which is x, will be n to the power n minus 3, because those two numbers, as powers, remember, must add up to the power outside the bracket. So n minus 3 plus 3, add them together, gives you the n outside the bracket. Now I'm only interested in the coefficients of these terms. In other words, I'm not interested in the x's themselves. So actually, the coefficient doesn't involve the x bit of this. The coefficient is just the number in front of the x bit. So n choose 3, forget about that, multiplied by 1 to the power 3 is the coefficient. And I'm telling you, or the examiner is telling you, that that is equal to 2 times the third term. So it's 2 lots of, the third term is equal to, n choose 2, third term, n choose 2, and it's going to be x to the power n minus 2, followed by 1 to a power 2. So that is exactly the same process that we applied there. I'm not interested in the x, so cross that out. So that is a true statement for this particular problem. So what we do now is we write the n choose 3 in this format. Well, if it was 7 choose 3, you'd have 7 by 6 by 5 over 3 by 2 by 1. That's how you'd work out 7 choose 3. So if you're working out n choose 3, you work out n by n minus 1 by n minus 2 over 3 by 2 by 1. That's how you work out n choose 3. The x is gone, we're not interested in that because I'm only interested in the coefficient. And 1 to the power 3, well that's just 1. And that's equal to 2 lots of, so 2 lots of n choose 2 will be n times n minus 1 over 2 by 1. In the same as 7 choose 2 would be 7 by 6 over 2 by 1. So n choose 2, n times n minus 1 over 2 by 1. X, I'm not interested in. 1 squared, that's just 1. What we've ended up with is a little equation to solve, and that involves lots of n's. But this is really easy, because what you're allowed to do is the following. You can see that on both sides on the bottom, you've got a 2 times 1 on the bottom, and a 2 times 1 on the bottom. So I'm going to multiply both sides by 2 times 1. In other words, the 2, 1 and the 2, 1, because they're on both sides, can just cross out. They can just cancel out. Also, you can see that I've got an n on both sides. I can just say, let's divide both sides by n. So I can just cross the n's out. I can say, there's an n minus 1 there and an n minus 1 there. I can just cross the n minus 1's out, because I'm dividing both sides by n minus 1. So what am I left with? I'm left with n minus 2 times 1, which is n minus 2 on the top here. I've still got a 3 on the bottom, is equal to, and on the right hand side I'm left with a 2. These have all cancelled, if you like, they give 1. 2 times 1 times 1 times 1 all over 1. And so this is just 2 times 1 on the right hand side. This is now a really basic equation. So you get n minus 2. What I'm going to do is multiply both sides by 3, times that by 3 you get that, times that by 3 you get 6. And then you get n equals 6 plus 2, so the power that we're talking about must be a power 8. So there you go. If we have x plus 1 to the power 8, then if you looked at the coefficients of the 4th term and the 3rd term, if you expanded it all out, you would find that the coefficient of the 4th term is 2 times the coefficient of the 3rd term. It's twice as big. Okay, that's one example. Let's do another one. So if I clear this, let's try a slightly harder one. So for question 2, what I'm going to say is, for question 2, that for, let's take the same expansion, x plus 1 to the power n again. Let's say that the coefficient this time of the 5th term is equal to 3 times the coefficient of the 4th term. That's what I'm going to say. And if that's the case, what we're going to do is find the value of the power n, find n. So here we go, 5th term. 5th term of that would be n choose 4. Power n, so we start with n choose. 5th term, so power 4, 1 less than the power. 1 less than the term, 5th term, so n choose 4. Okay, first term, x to the n minus 4, but remember coefficients, I'm not really interested in the x's, so cross it out. And then I've got 1 to the power 4. And I'm not really interested in that, to be honest, because 1 to the 4 is just 1, so I don't really need to put that in either. And that is going to be the same as 3 lots of the 4th term. The 4th term will be n choose 3. It's going to be x to the n minus 3 multiplied by 1 to the power 3. I'm not really interested in the x's, I'm only interested in coefficients, and the 1 to the 3 is irrelevant because 1 to the 3 is 1, times by 1 it doesn't change things. So n choose 4 is n minus 1, n minus 2, n minus 3, over 4 by 3 by 2 by 1. 1 to the 4 is 1, don't need to put it in really. Equals 3 lots of, and then n choose 3 is n minus 1, n minus 2, over 3 by 2 by 1. And then 1 cubed is just 1. We've got a little equation set up. All you've got to do is, well, 3, 2, 1, cross out, cross out. Same on both sides. It's the same as multiplying both sides by 3, 2, 1. Then we've got an n minus 1 and n minus 2 on both sides. So I'm going to divide both sides by n minus 1 and n minus 2. So I can just cross them straight out. What am I left with? I'm left with n minus 3 over 4 this time is equal to 3 on the right hand side. Everything else is cancelled out. So we get n minus 3 is equal to, times both sides by 4, you get 12. So that means that n is equal to 12 plus 3, 15. There you go. The power of n must be 15 for that example. I'm going to do one more, slightly harder, and that's the end of this topic. Okay, so number 3. For number 3, what I'm going to give you is a slightly harder binomial. So I'm going to give you 1 plus 2x to a power n. And this time I'm going to say the coefficient of the 5th term is 2 times the coefficient of the 4th term. And if that is the case, find what the power n must be for that to be a true statement. Okay, let's do it then. So, 5th term of that is going to be n choose 4. You have 1 to n minus 4, and then the second term is 2x to a power 4, like so. So notice you've got 2x to the 4 for this here. That's important that you put that in a bracket. That is important. Now what I'm not going to do this time at the moment is just cross that out like I did last time because of that 2. You get 2x to the 4. That's going to be important, that 2. We'll talk about that in a second. Equals 2 lots of the 4th term, which is n choose 3, 1 to the n minus 3, and then it's going to be 2x to the power 3. The 3 there, same power there, and that's n minus 3. that and that must add up to the n as the power of the bracket in the first place. Okay, so what I need to do now is this. N choose 4 I'll leave alone for the moment. 1 to the n minus 4 is just 1. I don't need to think about that, and I don't need to think about that, because 1 to any power is just 1. So I can just strike those out. But this time you see that this here is 2x to the power 4. If you have 2x to the power 4, 2x times 2x times 2x times 2x, that gives you 16x to the 4. Now I'm not interested in the x to the 4, but I am interested in the fact that we do get a 16 from that. The x to the 4 you can forget about. So the x bit you can cross out, and the x bit you can cross out, but you can't forget about the 2 to the 4, which is 16. That needs to go down. Equals, here you've got two lots of n choose 3, that's n by n, I'll leave it as n choose 3 for the moment, because I've done that on the left hand side. And then I've got 2 to the power 3, 2x to the 3, it's 8x cubed, but forget about the x cubed. So you're just going to get times by 8. So we get that. So what I got now is n choose 4, n minus 1, n minus 2, n minus 3, over 4, 3, 2, 1, times by 16 is equal to 2 times the 8 is 16, and then n choose 3 is n minus 1, n minus 2 over 3, 2, 1. So we have that equation to solve. Okay, 3, 2, 1, 3, 2, 1 can strike out. n minus 1, n minus 2, n minus 1, n minus 2. 16, 16. All of that can cancel out. So all I'm left with is n minus 3 over 4 is equal to, and on the right hand side if you look at it, what you've actually got is everything is cancelled out. So when I was getting rid of the 16, I'm dividing both sides by 16. So really what's happening is everything is becoming a 1. The 16 divided by 16 becomes 1. So it's 1 times 1 times 1 times 1 over 1 times 1 times 1. So you just get 1 there. So this becomes n minus 3 is equal to times both sides by 4. So take the 3 over, you get n equals 7. So n must be a power 7 in that situation. And that is a typical WJC exam paper question on binomial, whereby you're finding out the power of the n for the binomial expansion. And that's the end of this short video.